Now let's talk about regions and zones in GCP. Let's talk about how GCP connects the world through its global infrastructure. GCP has built data centers across the world, making its services available no matter where users are located. This is key to ensuring that businesses and applications can serve customers globally. GCP organizes its data centers into regions and zones. A region is a large geographical area, and within each region, there are multiple zones. One of the advantages of this combination of regions and zones is that it allows for better availability of your resources. You can optimally place your resources or distribute your applications to keep them running smoothly, even in the face of unexpected outages. And you have control over where your resources are deployed. For example, you can choose to store data or run applications in specific regions to meet performance needs or comply with local regulations. This flexibility ensures that your resources are placed exactly where they need to be, giving you control over performance and cost efficiency. With this setup, GCP not only ensures reliability, but also empowers you to customize where your services and data are located, making it easier to tailor solutions to specific business needs. This map gives you a clear picture of GCP's global reach. It's directly from Google's documentation. Each of these dots represents a region, which is a collection of data centers, not just one, but several working together in clusters. You can see how Google has placed these around the world, ensuring there is a GCP presence in a lot of the major areas. Obviously, there are parts that don't have it as much, but it's still impressive how much coverage GCP has. This scale allows GCP to provide low latency connections and high availability to users, no matter where they are. And remember, each region is divided into multiple zones, giving you the flexibility to distribute your resources and ensure redundancy. This isn't just about local coverage. It's about giving you the ability to control where your data lives, all while benefiting from GCP's vast global infrastructure. So, in GCP, a region is a large geographic area made up of multiple zones, which are essentially clusters of data centers. One of the big benefits of deploying resources in a region is that the resources within that region can communicate quickly and cost effectively with each other. And a zone is an independent data center or several within a region. These zones are designed to operate separately, meaning if one zone experiences an issue, the others within the same region can continue running. Distributing workloads across multiple zones within a region is a common practice to ensure fault tolerance. Essentially, your system stays up even if a zone goes down. As an example, we have the US East 4 region, which consists of multiple zones: US East 4A, US East 4C, and US East 4B. Each of these zones can contain one or more data centers, and they are all part of the larger US East 4 region, allowing for efficient resource communication and fault tolerance across them. For this certification, these concepts are relevant when deciding where to deploy a database and how to configure replication across zones or regions, for example. Now let's talk a bit about how regions and zones will feature in practice as you use GCP. Anything you deploy on GCP is tied to a specific location, whether that be a zone, a region, or even multiple regions. Let's take a look at how some of the core services are handled in terms of regions and zones. Buckets in cloud storage can be regional, dual region, or multi-regional, meaning you have the flexibility in where your data is stored and how it's replicated. Similarly, datasets in BigQuery can also be regional or multi-regional, giving you the ability to optimize for performance or availability depending on your needs. Cloud SQL is zonal, which means the database instance you spin up is tied to a specific zone within a region. So, for example, you will need to plan for failover scenarios accordingly. And clusters in the managed Spark are also zonal, meaning the computational resources you allocate exist within a particular zone. Additionally, you may assign a default region and zone for your project, helping with consistent deployment locations. These are just a few examples of how you might have to think about regions and zones as you use GCP. Regions and zones can sometimes feel like a minor detail, but there are key moments when they really matter. For example, you may face extra costs if data moves a lot between regions, or you could experience higher latency if your services are distributed too widely. Being mindful of this will help you maintain low latency, manage costs effectively, and ensure that your systems are fault tolerant. For this certification, one example where regions and zones are relevant is when deciding database location and replication strategy, such as cross-zone or cross-region setups. And that's it for this lesson.